Hi there. To whom it may concern, my name is Wong, and I'm currently studying as supervisor at Anaku Center at Berhad, a specialty mother and baby retail company based in Penang, Malaysia. Anaku has been running and operating for several years with a strong focus on providing essentials and quality products for modern parenting. We put relatively a large scale within the country per se, and we position ourselves as a cooking brand with carefully selected SKUs and personalized customer service. Our business includes both physical stores and now trending to a fully online presence. In my role, I oversee the business intelligence and operations support function. My team is responsible for converting raw sales and inventory data into insights that guide daily decisions, ranging from procurement planning to stock allocation and even promotional strategies. And during this internship placement, I had the pleasure of guiding Sean, the lead person, to join our business intelligence unit. It was really involving data cleaning, reporting, and sales performance analysis. One of his key roles was helping us to identify slow-moving SKUs and generate clean inventory reports, which directly supported our purchase decisions. It adapted relatively quickly to our data systems and tools, especially Excel and SPSS, and even contributed to our monthly review discussions with clear evidence-based findings. It would help us better to understand demand patterns, especially during key periods like Hari Raya and Ramadan. It was a valuable collaboration, and I'm more than happy to begin presenting the results of each project today.
Good morning, everyone. Good morning, Professor. Thank you for being here today. My name is Huang Xiaoyi, and my student number is 230868665, and I am Master of Applied Statistics student from University Malaysia. Today, I will be presenting my industry statistical project based on my internships and the local company, a leading mother and baby retail company based in Penang, Malaysia. The title of my project is Statistic Analysis and Inventory Optimization in the Malaysian Mother and Baby Retail Company. During my internships, I worked with a great data team that used the statistics to solve real problems in retail. At the company, I learned how hard it can be to manage product stocks across many stores, especially when dealing with the festival and the customer habits. The goal of my project was to see how data analysis can help the company plan purchase and manage store better. I looked at the 3 months of the sale data from March to May, covering thousands of product records. This project helps the company make smart decisions based on the data and also helped me get better at using SPSS, Excel, and making business reports. The company is a local brand based in the Penang that focuses on the quality mother and baby products. It is a small boutique style company with only a few physical stores, but it serves a loyal group of the customers. The company sells both daily items like the baby diapers and the milk powders and the higher-end products like the toys and the big stores. This industry is growing as more parents care about the baby health and safety. But small retailers like this company also face the challenges. For example, festival seasons like the high roller in the April and the suddenly changes customers' demands. So the company must plan stock carefully to avoid selling out or having too much left over. In this company, I worked in the business intelligence department, which cooperates close with the sales, procurement, logistics, and finance teams. The BI team helps turn sales data into useful business idea. My job includes clearing and organizing data in Excel and doing simple analysis in SPSS. I helped the team by making weekly and monthly reports, finding out which products sell well, and checking how fast stock was moving. One of my main tasks was to find slow-moving products and suggest how to adjust the stocks. This experience helped me understand how data and statistics are used in the real business decisions. The main goal of my project was to use the statistic to help solve problems with inventory. More specifically, I focused on number one, finding products that sell well and those that don't. Number two, looking at how much each SKU, brand, category, and store adds to total sales. Number three, studying how sales change over time. And number four, giving useful advice to help with buying and restoring decision. So I use the sale data from the all story between March and the May 2024. Sorry. This time include the festival season, so the data showed a full picture of how sales worked during that busy time. To do this project, I use a mix of simple and useful statistical methods. This include number one, descriptive statistics to understand the total sales, average sales, and how products were selling overall. And number two, contribution analysis. I use a lot of different formula. This shows how much each product or brand adds to the total. And number three, SKU ranking, a result of the products by quantity, sales, or revenue to find the best and the worst performers. And number four, cross turbulations. It can do comparison like the sales across stories and the product categories. I use the SPSS software to do all of this. It helped me organize the data, make charts, and do the calculations easily. This method was not just for school. The real helped me to calmly to make a better decision. So let's start with our first experiment. I looked at how promotions affect monthly sales and the revenue. To do this, I grouped the sales data based on whether there was a promotion or not. Then I calculate the total quantity and the total revenue for both groups. From the SPSS output on the slide, we see that the group with the promotions had much higher avenue sales. The t-test results are very significant, with p-value less than 0.001. So that means the difference is statistically real, not just random. We also calculated the effect size. You can see the three different data. We can see all values are very above 0.8, showing a large effect. So promotion didn't just boost sales numbers, they had a strong impact. So this results tell us the running promotions can really drive sales, and should be considered in the future sales planning. So moving on the second experiment, I focus on how different products categories perform. I group the products into the categories like the block X, block Y, and block Z. Then I ranked each category based on the total sales quantity and the revenue. The charts on the slide show that the brand X and brand Y sold the most. That makes sense because in the April, many families were preparing for the festival. So that's essential and higher demand. On the other hand, the brand Z performs poorly. This may mean no demand or poor products the visibilities. So let's take raises. We should consider giving more support to the underperforming categories, maybe with the promotion or better shelf space. And next, the part is about the understanding short-term sales trend and the stock risk. I use the SPSS to check how much each SKU sold in each month. The 9 charts on the slide show sales quantity over time. That even though the sales went down slightly, the p-value is 0.333, which means it's not statistic significance. So we can say the decrease is real. It may just be random. And then we also see this in the regression table. The bet is the minus 4.000, but again, it's not significant. Still, from the table sales data, SKU P005 is clearly selling less than the other. This may need attention. Maybe reduce stock or offer promotion. Checking each SKU's performance monthly help us find the slow there early. Then we can take action before it becomes a biggest problem. And this slide is about experiment 4, SKU performance and slow-moving warning. Let me explain what we did here. First, we ranked all SKU based on this total sales revenue, not just the number of units sold. That means we look at the money each product brought in, not just how much time it was sold. Interesting, we found that selling a lot doesn't always mean making a lot of money. Some products that sold in smaller amounts actually generated high revenue. On the other hand, some products that sold a lot didn't contribute much to total revenue. The table on this slide shows the total sales quantity per SKU and whether it was classified as a slow-moving. For example, SKU P005 had the lowest sales quantity and was flagged as a slow mover. So this tells us that we should look beyond the sales value and also consider profitabilities. So the recommendations here is to focus on promoting high margin products and maybe stop or reduce this with a high revenue but low revenue. And now let's move into our number 5 experiments, which look at the relationships between product price and sales quantity. The goal here was to find out whether price changes had a significant effect on demand. I used SPSS to run a linear regressions with an average unit price as the product and the total monthly quantity as the dependent variable. On the regression results shown here, you can see that the model R squared is quite narrow, only about 0.005, and the p-value is a 0.778, which is not statistical significance. This suggests that in our case, price didn't strongly explain the changes in sales value. This could be due to many items being daily essential with the relative fixed demand. So even if price changed a little, customers still buy them. The identifications here is that price alone may not be a useful lever to increase sales for this type of product. Manager may consider focusing on the availability and the convenience instead. And finally, we come to our sixth experiment, which focuses on the identified high-value products based on the unit price. The aim was to understand which SKUs bring higher value per unit sold. In this part, I use the SPSS to calculate the average price per unit by SKU and sort the results to highlight high-value items. And you can see from the charts, SKU P001 has the highest unit price, followed by the P005 and P002. The SKU are likely the premium products, which contributes the more revenue despite not being in the top in the quantity. That means we should not only look at the value, but also at the profitabilities. High unit price items may deserve more marketing attentions, even if they sell less frequently. So this action here is the identify and promote high margin products to improve overall revenue essentially. And to sum up what I found, I think there are 5 aspects I will consider. Number 1, a small number of SKU bring most of the sales. And number 2, and list on products is selling very badly. And number 3, some products are affected by festival seasons. And number 4, different brands should be different in sales performance. And number 5, some products have more chance to sell better. So this finding helps the business teams know how to improve, and they can decide to stock more of and what to promote and how to use the brand better. And based on what we find, I suggest a few actions. Number 1, make a monthly report to track slow-moving products early. And number 2, give more shelf space and the purchase order to best-selling SKU. And number 3, use the different restocking rules for different brands. And number 4, do clear sales before a big holidays like Harry Royal. And number 5, make sure BI and the different department teams work together and update data often. So doing these things can help the company work better and make customers happier. So that's in shape give me a chance to use what I learned in class in the real companies. I learned how to clear and change and study large set of data. I also become good at using SPSS, and I learned how to make business reports. More importantly, I saw how data and statistics help companies make smart choices in buying, stock control, and marketing. It helped me understand the real job of the statistics in the business today. So thank you very much for listening. That is the end of my presentation. If you have any question, I'd like to happy to answer. Once again, thank you for your time and attention.